The quartic function t is defined as t of x is equal to x squared minus 5x plus 2 multiplied by x squared minus 5x plus 4, where x is a real number. Part A, find the 4 roots of t of x, giving you answers to 3 significant figures where necessary. So, 4 roots is when our function equals 0. That's how we find the roots. So let me write out the t of x and make it equal to 0. So this is going to equal 0 either when x squared minus 5x plus 2 equals 0, or when x squared minus 5x plus 4 is equal to 0. Now the second one is easy to solve because we can just factorize that. X minus 4, x minus 1, the minus 1 and the minus 4 multiply to make the plus 4. The minus 4 and the minus 1 add to give the minus 5. So that factorizes nice and easily, so we can get the 2 roots of 4 and 1. The first quadratic there, the x squared minus 5x plus 2 equals 0, doesn't factorize. But that's fine, we can use the quadratic formula on that, where a is 1, b is minus 5, and c is 2. So using the quadratic formula, we find that x is equal to minus b, plus or minus b squared minus 4 times a times c divided by 2a. And if I substitute that into my formula, I find the 2 answers for x are to 3 significant figures, 0.438 or 4.56. So these are my 4 roots of t of x. Part B, sketch the graph of t of x. So let's draw a set of axes. There's our y-axis, here's our x-axis. So we're sketching a graph and we need to show the coordinates of all the points where the curve meets the axes. Well, we've just found the 4 roots, so let's plot them on. We've got the root at 0.438, we've got the root at 1, we've got another root at 4, and another root at 4.56. Let's also find where it intersects on the y-axis as well. It's going to intersect on the y-axis when x equals 0. So if I substitute 0 into this original t of x function, I find that I just get 2 times 4, which is 8. The other thing to bear in mind is what sort of shape this is going to be. It's a quartic. Let's just double check whether it's a positive quartic or a negative quartic. Remember, positive quartics will look like this normally. Negative quartics will look something like this. In this case, it's a positive because if I did expand this out, I'd have a positive x squared times a positive x squared, which would give a positive x to the power 4. So that means we can draw it in like this. It doesn't matter for now how far you draw your turning points. I've drawn mine like that. If you've drawn yours a bit more sort of further down, that's fine as well. It doesn't matter for now. We will work out at a later date how we can work out the exact coordinates of these points here. So it doesn't matter. As long as you've got your shape looking like a kind of W here, and as long as you've got it going through points 8 on the y-axis and our 4 roots on the x-axis, then that is absolutely fine.